right, well, here we are. We're in, I don't know what week it is of quarantine. I feel like I've been living in my basement for a long time. I'm that guy who lives in his basement. It's at least my own basement and not my parents' basement, so that's a thing. Today we're actually going to be looking at section 7.2, which is the multiplication of monomials. Let me go ahead and switch to the notes here so you can see what I'm seeing. So the multiplication of monomials, what we're doing here is we've got a variety of different, or I should say a combination of a number of different bases coming together. So when we have something like, say for example, x to the 7th, we say that x is the base, right? The base is just whatever is being raised to a power that has an exponent. 7's the exponent. The exponent indicates the number of times the base occurs as a factor. So you have x to the 7th is basically x multiplied out times itself 7 times. Okay? Now the rules for multiplying these things together, what we do is that if we have, say, some x to the m times x to the n, so they're two separate, two different distinct exponents, but they have the same base. What you do is you combine them to have the same base, and then you simply just add the exponents together. So in this case, it's m plus n because I've got x to the m times x to the n. So I add the exponents. I'm not multiplying. I'm going to be adding the exponents. There's a page 313 in the textbook. If you can go to that, there's tons of examples for how that works. Really encourage you to go check that out. So when we're simplifying the powers of monomials, we add the exponents together. So the question is, what happens when you raise a variable with an exponent to another exponent? It's like Inception almost. You've got exponents of exponents going on. Dreams of dreams, right, is the movie Inception. If you haven't seen it, it's a great movie. You have exponents of exponents. So what do we do with something that's like this? X to the 3rd raised to the 4th power. So if we use the same rule that we had up above, so if you see this guy, right, you're just multiplying whatever this is. You kind of treat this like it's your base to 4 times. So you got it x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. That's the same thing as x times x to the 3rd times 4, or I just changed it. I flipped it here in the notes, but you can think of it as x to the 3rd times 4, which is equal to x to the 12. So you're actually multiplying. So when you are multiplying the same base, different exponents, you add the exponents. Down here, I'm raising something with a base to an exponent. So I've got an exponent raised to an exponent power, or raised to a power right there, an exponential power. You multiply. So it's a little bit different in that regard. So here's the general rule, right? If I've got x to the m raised to the nth power, this is the same thing as x to the m times n. Now, you can actually do it for multiple products. If you've got multiple things combined together, so x to the m times y to the n raised to the p power, it's a lot going on there. We're taking the p and we're multiplying it by both individual exponents. So we've got x to the m times p. The p goes to both of those. So x to the m times p, y to the n times p. Okay. Now this is all like, okay, great. Like, how does this actually work in examples? I'm glad you brought that up, because what we're going to do is a bunch of examples. You know how I am. This is how I work. All right. So these are similar questions to what you'll see on the homework. Let me just go ahead and do just a few. They're all pretty similar, actually, so it's just some of the context associated with them it might change up a little bit. So this one is minus 3y times y. Okay, this is the same thing as well. Let's just think about it, right? Let's just multiply things across. So I've got minus 3 times y times y. Okay? When you see a y like this, you can assume that it has an exponent of 1. So if you think of it like this, this is the same thing right here as minus 3 times y to the 1 plus 1. Right? Remember, we add those exponents together. So now this is the same as minus 3y squared. Right? And I think you probably would have figured that out, right? When you multiply these things out, you are multiplying a y times a y, you get a y squared, and it's pretty similar to what we get over here. All right, question 16. I've got x squared y to the 4th. Let's see here, times x y to the 7th. Okay. Now, one of the things that you can do if you're getting started doing a lot of this is to separate the x's and the y's together. If you've got different bases represented down below, completely separate them out. So here you can do x squared times x. So I'm basically just rearranging things here. And now this becomes y to the 4th times y to the 7th, which is the same thing as, again, remember that's a 1, x to the 2 plus 1, y to the 4 plus 7, which is equal to x to the 3, y to the 11. Okay? So that's actually what we're doing here in this case. Remember, when we're multiplying things out like this, we're just going to add the exponents together and combine the bases. Okay? So there is a couple questions there. Let me go ahead and I'll do a few more, of course. These are super handy for a lot of content that we're going to do. In fact, the next section, section 7.3, which I'm probably going to post the video of that one tomorrow. That is probably the most important section that we will cover this entire semester. So I'm really going to try to take as much time on that one as I possibly can. All right, let's do another one. X squared, y cubed, z. I just realized this thing is going on YouTube, so when I say tomorrow, I'm actually referencing Wednesday, April 8th. That would be tomorrow. Today is the 7th. So, FYI. If you're watching section 7.3 and you're like, what the heck? Yeah, that's why. All right, x cubed, y to the 4th. Okay, so this is the same thing. Again, let's go ahead and combine all of our like terms or like bases. So what we're going to have is x squared times x to the 3rd times y to the 3rd, y to the 4th times y to the 4th times z. There's no z over here, so that's just all we have. And you can think of this again as z to the 1st. So now we combine these up. So this is going to be x to the... I'm really taking time writing all of these out, okay? Because we'll go a lot quicker through these here in the future, in the next probably few sections. I'm going to assume you know how to do all this, and so I'm probably going to go quicker. So now x to the 2 plus 3 is x to the 5th, y to the 7th times z. And that's our final answer. All right, let's do one more. 38. 3 a, b. This is like the hardest one, I think, on here. Minus 2, a, b, c. Got lots of things going on here. 4, a, c squared. Okay. So now what I want to do is I'm going to encourage you to actually go ahead and combine, just like we were combining up here, the things that were all the same. So the x's are together, the y's are together, the z's are together. We'll do the same thing down here. We're just going to combine the numbers actually first. So this is the same thing as 3 times a negative 2 times a 4. Okay, so there's our numbers. Then we're going to do our a's. A times A times A. We'll do our b's. B squared times B. And there's no B back there, so you don't write 0. You just leave it. Okay, it's just times 1. And then this is going to be no C there. There's a C there, so we'll start with the second one. And then this is going to be C squared. Okay. So now we multiply all this out. 3 times a minus 2 times 4. Any guesses? You'd be right if you guessed minus 24. 3 of those, there's a to the third. B squared times B is B to the third. C times C squared is going to be C to the third. Look at that. Everything is raised to the third power. All right, let's just jump ahead. Now we're going to jump to the section where it's regarding products. So we're raising bases with exponents to more exponents. I always say that you're not having a good time or having a good party unless you're raising bases of exponents to more exponents. That's my rule of thumb for parties. 46. All right, so now what we're going to do, y to the fifth raised to the third power, this is equal to. Now what we're doing, again, you can think of it, I'll write this first one out, but then we're just going to go ahead and just start multiplying. So this is the same as y to the fifth times y to the fifth times y to the fifth, which is equal to y to the 5 plus 5 plus 5. Which is equal to y to the 15th, okay? So now you could just take this jump. Okay, y to the 5th raised to the 3rd, 5 times 3 is 15. There's our answer, right? You can do that. That's fine. In fact, I'm probably going to start doing that here a little bit. But it's not a bad idea to just write this out, especially early on. So now this one, okay. Who here loves taking negative numbers and raising them to exponents, right? Remember, there's certain rules that you have to do when kind of working these out. Well, if you love that, you're going to love this even more because we're raising those to more exponents, right? All right, so there's two ways to do this. I'm going to do the first way. And the first way would just be, hey, like, this is a number, so let's just figure out what the number is and then raise that number to the third power. You can do that. That's completely fine. So let's just do that. Minus 2 to the third is going to be minus 8. And you're probably like, whoa, 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 dude. It's a minus. Well, yeah, it is. Remember, the minus 2 itself is not being raised to the third power. It's minus the 2 to the third. So it's a minus 8. Okay, so this then is going to be raised to the third power because of that. And now we've got, this is going to be minus 512. Now, I'm going to show you the other way to do it, okay? I like giving options. There's a whole, slew of different things that you can do in math. It's not just one or the other. But we'll just do it one of two ways. So the other way to do it is you can think of it like this. You can think of this right here as like a minus 1 times a positive 2. Let me say that again. This is like a minus 1 times a positive 2. So minus 1 times 2 cubed. That's another way you can think about this, raised to the third power. So this is basically the same thing. I take the 3 and I'm raising it the minus 1 to the third power as well. So this is actually like a minus 1 to the third times 2 to the 3 times 3, which is equal to a minus 1 times 2 to the 3 times 3 is 2 to the 9th. That's a 9. So 2 to the 9th, this is the same thing as negative 1 times 512. There you go. So that's another way to do it. You might think, well, that's way more complicated. Yeah, it might be, but it's another way to do it. So you might like that way better. All right, question 60. x cubed, y to the 4th, all raised to the 5th power. So now, again, what I'm doing is I'm multiplying this out. X to the 3rd times 5, y to the 4th times 5. This is equal to x to the 15th, y to the 20th. All right. Let's do one last one. This is actually a pretty quick lesson. How about that? Some of them are not terrible. I guess it helps too that I probably, just in terms of going through it faster, I don't have you guys asking me questions, which I love. I love it when questions are asked of me, so don't take that the wrong way. It's just the nice thing about this video format now is you can go back and watch it and watch me do it as many times as you want. All right, question 80. So now we've got minus 3a squared b to the 3rd. Oops, I made a mistake here. Hang on, let me go back. That's just times b, and this is all raised to the 3rd power. Times minus 3ab cubed. And so now what we have to do is multiply all this out. Okay, so we can use kind of a combination of our methods. Previously, I said, hey, why don't you take the things with the same bases and combine them together and then multiply them all out. You can do that, or you can just go straight through it. That's fine by me. I'm going to go that earlier route. I'm going to work this one out for you so you can see all the steps. So this is the same as a minus 3 all raised to the 3rd power. So I'm going to distribute these 3's and raise each of these by the 3rd power. So a squared to the 3rd is a to the 6th, because I have 2 times 3. B to the 3rd. And I'm going to be multiplying this by a minus 3 raised to the 3rd power, a to the 3rd power, b to the 3rd power. Okay? Just distributing those exponents. Alright, so now minus 3 to the 3rd is actually going to be minus 27. A to the 6th, b to the 3rd. Minus 27, a to the 3rd, b to the 3rd. Right? Nothing changed really there. Just multiplying out the minus 3 to the 3rd power on both sides. So now we can go and do what we were doing the very first part. So we can combine just our common terms together. So you get minus 27 times a minus 27 times a to the 6th times a to the 3rd. And again, this all works out because everything is just multiplying. Previously, if you're adding things up and there's things in between that are adding and subtracting, it's just you can't do it that way. So this is a little bit different because we're just multiplying everything out, so we can move things around a little bit more freely. A cubed, this is going to be, so that's our a, and now we got to go to our b's. So b to the 3rd, b to the 3rd, so there's that one, and we're done. Okay, so last but not least, we multiply this out, we'll get 729 a to the 9th, because remember we add those exponents together, and this is going to be b to the 6th. So that is our final answer right there. So that's section 7.2. If anyone has any questions, feel free to let me know, and I will be seeing you at some point.